guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Let's do something different. This is a Henry Electronics RF amplifier. It's for 146 megahertz. It does 250 watts continuous. This is your RF input. It's your RF output. And on the inside there's no keying circuit. No auto key circuit, no sense circuit, no nothing. This is designed to be used as a transmitter. Okay, so you're going to put power in here. More power is going to come out of here, and you leave it and turn it on. That's what this thing was designed for. But we're going to make it work on the 2 meter band, which is pretty close to this frequency. Like, really close to this frequency. So there's very little we're going to have to modify in here, other than our coax connectors, an on-off switch. We're going to have to add a relay and do some other little magic to this thing. So, away, you and me, go. just know someday I'm going to have myself like a aircraft guy or satellite guy or some other radio guy that used to build shit by hand call me and tell me, you know, I watched you hand tie one of these things one time and you're doing it wrong. And I'm kind of looking forward to that day, because I know I'm not doing this right, but it looks pretty goddamn close. I had to trim all the ties out of there because I took the old input connector and we've now moved it down here in the lid, down here. This is where our new power wire connection is going to come, because this connection is woefully inadequate for the way that the guy that's going to own this thing is going to run it. And they had to coax interweave through all of this, and it came down through here. Well, as you can clearly see, our new input circuit's going to be back here in the back. So I went ahead and I wired up an on-off switch for him with an LED indicator. His power wire is going to come here, and his two new coax connectors, output and input, is going to be down here. So I wanted to remove all of this, the mini coax that was in here, so I had to retie all of this and retie all of this. Then I ran the remote wire for the relay, which I'll show you here in a minute, down this length through this bus, which then I had to hand tie this up here. And I'm pretty sure how this goes is square knot hitch, square knot hitch, square knot, and I just do chain and then square knots at each end, and I'm pretty sure I'm doing this wrong, but we checked the thermocouple that turns the fans on and off, but it is direct bolted to the heatsink, so therefore we have faith it's going to run, unlike the other boxes where it's in there and it's mounted to the PCB board and I just bypass it. This will actually work well for this guy. Okay, so last step is coax connectors, and I think I'm going to use 316DS here because of the low loss rate, and then I'm going to do RG400 here, and then I scavenged this conical down cone sizer for the output side. So let's work on that next. Wow. So I just spent 3 hours educating myself on how to get the pass-through on this thing stupid low. Now this is going into the dummy load. Okay. The dummy load is not naturally resonant. Well, it's resonant for this frequency, but its response is not as well as the actual antenna that's on the outside, which I was tuning to. It's actually got like a 1.01, but I had to change. I managed to salvage this downsizer bit and had this in play. The problem was when I went to close the cabinet, I couldn't close it because of the new relay that we installed for the input and the output. And the trick to getting this to lay down was making the coax so it terminated and then shielding. The shielding of the relay made a huge difference. And the problem with that is that the HF frequencies, the waveform's slower, so therefore the impedance bump isn't as drastic. Where at this frequency, the higher, shorter frequency, the exposed wire makes a huge difference in how well it actually is gonna conduct. And it doesn't matter what kind of capacitance I added to this, I could not get it to come down, so I ended up just shortening up all the coax leads, including the input coax lead, shorten it way up. And when I did that, then it went bloop, fell down flat. So we've got our key-in circuit installed now. We've got our on-off, our LEDs, our PL259s. We've got a good pass-through. When I come back, I'm going to use a 250 watt slug that is 100 through 250 megahertz. I got that hole blanked out because we are going to be running an FM. That hole blanked out because we're going to be running an FM, and I don't want to have any RF leakage, and I want to see what it looks like on the spectrum analyzer. So there's two little things left in here I want to change. I'm going to do that really super fast, and then we're going to get on to running it. So give me just a second, and we shall return. This was a pain in the buttocks. Big time. All right, let's sit down and have ourselves a little safety chat. I don't like working on these little 2-meter boxes like this. I don't. I'm not a fan. This isn't my jive, man. We've got to be serious, though. This amplifier is designed to be turned on and run, okay? It's designed to put out 250 watts max, and that's it, all day long, 24/7, 365. Okay, it's forced air cooled here and on the back side with two 120 millimeter fans on the back. The slots inside this cabinet here for the exhaust are engineered to a certain opening and a certain length, and the reason for that is to help keep the genie inside the bottle. It doesn't block the wave, it traps the wave. It's really quite cool how this works. It works the same principles as like on your microwave door. Your microwave door, when you close it, for the first nanomillisecond when you turn the microwave on and the cavity gets flooded with RF, the electrons actually run up, meet the exit holes that you're able to see through, and the RF electrons start to do this. And they create a shield. Because the opening is not truly resonant, semi-resonant, the energy itself actually blocks the leakage or the ability for the RF to leave. This is a highly engineered opening. Behind the screen, or behind this fan's 100 or a million grit or strain stainless steel screen. It's doing the same thing. It's protecting you. At this frequency, you can cause damage to the soft tissue in your eyes and to your skin at high level exposure for a certain amount of time. We get very cavalier around the HF bands. Man, I'm gonna get me a gigawatt. That's great, man. At the lower frequencies, the RF doesn't interact with us, the mostly soft, fleshy bags of water that we are, too awful well. The water is very dense to that frequency of RF. When you go higher in frequency, the RF can interact with the molecules of moisture in your body and get them excited and make them rub against each other and bounce off each other, causing heat. That's how your microwave works. It's simply heating the water. It's making the molecules of water move around. There's a huge frequency difference between this and your microwave, but as soon as we leave the HF band, you have to start thinking, and seriously start thinking about our RF exposure. Now, where this is going, the guy's got hardline, got a good antenna attached to it, good grounding, he's got all the stuff, and the emission point for the RF is going to be well away from him. Okay. Do not take this lightly. This is still only a couple 100-watt amplifier, but as you'll see in the next little bit of video, I never ran this without the lid off of it. When I went in there and made the adjustments to the inside of the box to bring it to down in frequency a little bit, which was, there's two trimmer capacitors, I had to match it perfectly, by the way. And that involved matching it with the spectrum analyzer, matching it with the watt meter, and then physically disconnecting one side of the trimmer capacitors and measuring them to make sure they were the same capacitance value. I never ran this without the lid on it. Keep the RF in the bottle. Okay, safety lecture over. Here we go, let's run it. It's very anticlimactic, by the way. 25 watts in, 200 watts out. On the outside of this thing, the data sheet says no more than 30. That's for continuous operation, because this is a on-state transmitter. Once you put it into operation, there is no standby. Okay, this is built for an industrial application. But, well, we simply made that we could use it our way. I cannot stress this enough, by the way. This is not something I want to get into doing. This is not something I'm interested in doing probably ever again. It was a fun little learning curve. I've built multiple devices for my own personal use, for experimentation, and for research, so I understand how to do this, to work on these. But the thing that I thought was really interesting was that I could not have more than 1/4 of an inch worth of center conductor exposure without having some kind of reference to ground on the inside of this thing, without it dramatically changing the tuning. It took a few minutes to get my head wrapped around, like about an hour and a half. Once I did it, I was like, oh, okay, and just applied it everywhere, and oh, look at this, it works great. So, if it wasn't for my very advanced network analyzer that I own, I would have been spending a lot more time on this, and I thank God for decent test equipment, and I'm grateful that I was able to get that beautiful network analyzer many years ago. So, on that note, Here we go. The amplifier off. Let me grab this microphone here real quick. It's about 20-25 watts. I'd say 25 watts right on the button. Remember, we're reading this top scale. A lot of people, they have a hard time reading anything that ends with the 250 watt element, okay? Reading this top scale, so full deflection is 250, 200, 150, 150, and then we divide that in half again, that's 25. Spectrum analyzer. We are 100 kcs or 100 megahertz wide. Okay, center's at 144. We're starting at 94 megahertz, and our stop is 194 megahertz. This is important because we have to establish that there's no second and no third order harmonics, especially at this frequency and the bandwidth that you might possibly be using it on. Okay? Very clearly, not doing anything where we shouldn't. Let's go down here, flick the switch, 200 watts, booyah. Nothing. Nothing. And that's what we were wanting to see. Now, this does have a temperature sense in it, which is basically like a thermocouple, or it's a thermal activated switch, to where if we keep this in transmission and we get enough heat soak into this fan's going to kick on. It's like right now we're just throwing about a 200 watt carrier out there, and we're pulling 80 amps. We get enough heat soak into this unit, these fans will kick on. Now when I tested the unit, it said it wouldn't turn on until it got, I took an air gun and blew on the little thermal switch in the back, and it would not kick on until the unit got to 180 something degrees on the heatsink side. I don't know how long I want to sit here and heat soak these transistors like that. But this comes with a serious note of caution to the end user. Please protect yourself, be smart about it, be vigilant in what you're doing. To go up in output power in 2 meters can possibly hurt you. Okay? I built several little 2 meter experimental amplifiers for myself over the years. And I will not build them for anybody else. I will not do it. I will not do it. Now, if I did do anything, it would probably be with an LD MOS unit in the future. Something that you can put 3 or 4 watts into and get a nice smooth kilowatt with very little shmoo extra added to it. I wouldn't mind doing one of those, but I'm going to probably do that for myself. Just saying. But I'm grateful for the guy that I work with that's kind of like a student and a good friend of mine that was willing to send this here to me for me to be able to do this for him. Learned a little bit, taught myself a little bit. This was actually fun, but it's done, so I've got to get it out of here and down the road. All right, enough serious time. Titty, boobs, and beer. Okay, gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come find me, www.bbiamps.com. You can find me on Facebook, Twitter, Snapchat, Instagram, and right here on the YouTube Gargler. It's a very straightforward Henry 2 meter amplifier that we just simply put a relay in a keying circuit and upgraded the power wire. On that note, gentlemen, I'll see ya. Bump, bump.